Okay. So just to recap, so just now what we learned about is a history, no? Okay, it started with the safety gear, and then invention of the electric lift, and then the invention of the motorless lift, and then we talk about vertical transportation in Malaysia, and then we talk about the regulation, no? Factory and Machinery Act, and we talk about competent person, grade 1, grade 2, grade 3, and their role and responsibility, and we also talk about discuss the importance of the lift inspection. Oh, Lance, you have anything to add?
So far so good.
So far so good, huh? Okay, we go to module 2. So we will talk about fundamental of lift design. So the keyword is fundamental. We talk about fundamental only. Yeah. Okay. Traffic requirement of the lift system. Okay. Lift system shall be designed in such a way, in such a manner that it can meet 5-minute handling capacity ratio and average waiting time requirement. What is the meaning of this 5-minute handling capacity ratio and average waiting time? Why is 5 minutes? Why not 10 minutes? Any guess? 5 minutes is actually the rule of thumb for most of the lift engineer. For example, 8:30 a.m. 8:30 a.m. your office hours start. They want to ensure that from 8:25 to 8:30, it can handle big enough traffic because people usually, because that will be the peak hour, so we call it as a morning peak. So morning peak will usually be up peak because people will be going up to their offices and so on. Then there is another peak, so-called inter-peak lunch hour. There are people moving up and down, and the down peak, that means after working hour, people are rushing from their office and want to go home. But for lift engineering perspective, we are more concerning about morning up peak, and then we also have the interfloor traffic during lunchtime, as I mentioned just now. People going out for lunch, after going back from lunch, down peak. So most important is actually up peak. Why up peak is most important? You don't want to get late to go to the office. And average waiting time. So average waiting time is the time that you need to wait at the lobby once you have pressed the button.
Should be less than 1 minute lah.
There are some requirements, no? Hospital, hotel, apartment, and so on. And low density residential building also have their different requirements. But that actually is very subjective. But the lift company, they will discuss with consulting engineer usually. So actually there is a method to handle this. So this 5-minute handling capacity ratio is a quantitative performance. How many people? And then average waiting time is the qualitative, your satisfaction. The longer you wait, the more frustration you are. So actually last time, when we designed the lift, actually we have encountered this problem. When the engineer they design the lift system, they consider 3 lift or 4 lift. But somehow it still get a lot of complaint for hotel. In KL last time I received the complaint because sometimes the travel bus they carry a group of tourists. When they want to go in, suddenly jam at the lobby. But too late . So that's why in hotel usually you see how many lift in the lobby. Maybe usually what is your rule of thumb?
Easily 4
or 5 lift. 4 or 5 lift. But actually most of the time the lift are not utilized. 哦，这样
嗯
哦，but you still have to design, you still have to have the number to ensure that people are happy.
Yes, because of the check-out time
Check out, check in,
of
yeah.
the tour group.
Yes.
Like after breakfast, 8 o'clock, jam.
The hotel will put the welcome drink near the elevator area.
I think
yeah.
importantly for them to catch the flight sometimes they don't have to
due to
do
whatever
this,
reason
this.
But we there's a rush hour and peak hour and not so in relaxed hour lah. So we will adjust.
You adjust
Full capacity 5 elevator.
Yeah.
Less
So-
people maybe 2 or 3.
2 or 3.
Elevator
But one of the problem with the hotel lift arrangement is it often have the lift facing each other. So sometimes when the lift at your back came so you may not come in, you may not aware So that's why some of the company we suggest to have the arriving ring to have a notification, a bell, something like that. At least you can notice the lift is coming. So now you see 5 average waiting time. Need to wait for the lift to serve him upon arrival to main floor So when he press the button So actually now there are some lift company they already design the so-called the pre-landing call. That means you are still at the lift lobby is still somewhere around you, but actually they already can have the post they can already press already, and then some of them I heard they also can make the call through the apps. This is what I heard but I haven't seen it by myself. 5 minute handling capacity ratio is a ratio to population of the tenant inside building. You can do typical 5 minutes of morning update.
You are right, totally, because basically hotel one you cannot predict when the update, unlike the office tower, you have more, you can actually know the number of the occupants in the building and then design it according to the needs. But for hotel, it will be subject to season and the timing.
Rule of thumb is actually 4 lift usually 4 lift usually 4 lift. And then another strategy when last time when we make a proposal to hotel is have a zoning, and we always ask them to have the separate lift for car park. So if you can just imagine if everyone will go to car park, will go to the hotel room and the podium and seminar hall with the same group of the lift, I think you will not be having enough lift. So that's why I think usually this
Most is still practice the same.
that's why we usually ask them car park lift
4+1.
have a different zone. Then round trip time is the total time consumed for the lift to make a round trip to serve average stop floor. Round trip time start when the lift door close. This is the definition. Lift door close at the main floor, and then ends when it reach the main floor and the open to discharge passenger. What does it mean? That means when the people go into the lift, the door close, then it will move up, stop. Then after that it move down again, the lift door open. That is actually round trip time. This is also definition. How the lift engineer define, I think they should have their consideration. So this kind of round trip time is actually influenced by number of floors,
And number of lift.
number of lift, and then size of the door opening, capacity of the lift. I mean, the bigger the capacity of the lift, the more people can come in. So our rule of thumb is we always consider 80% occupancy.
And the lift, if not mistaken, it have to be in a group. Only the round trip time can be reduced by number of lift.
Yes.
Otherwise, the round trip time won't be reduced, even that you have separate single.
Yes.
And not in group, then you won't be able to reduce the RTT.
Group control. So the most basic lift group control is a duplex, followed by triplex, and 4-car group. Okay. Then expectation. Average waiting time less than 30%.
Second.
Second. And the 5-minute handling capacity ratio is it can handle 10 to 15% of the user or the tenant of the office hour. So this is rule of thumb. I mean, this is developed or defined by lift engineer from those days until now. So as you can see, round trip time, waiting time, call registration, transit time, and so on. So this is the starting time. You see, 30 minutes. 5-minute handling capacity ratio is always the big one. Because people always tend to go into the office last minute. This is from the survey lah. This is from the empirical data. It's not based on any formula, but based on the empirical data collected by the lift engineer throughout the years. So desirable plans. So bank of 4 elevator, inline arrangement. So what will be the advantage of this kind of arrangement?
Easy to see.
Easy to see, easy to see. But for architect, they may not be happy. For architect, they may not be happy because they require a lot of space for the lift staff in one row. This is usually in hotel,
Yes.
in hotel. Then group of 8 elevator facing this one usually is for the high speed lift. High speed lift. And then 2 bank facing arrangement. This one sometimes they have the low zone and high zone. Actually, you can see this kind of the zoning in where can you find this special zoning? Công correct or not?
Yes.
Công I think they have different color.
Yes.
The elevator different color.
Different color. So this is undesirable plan. 2 bank inline arrangement. This is very bad because they have the different group control, so they are not synchronized. So this one, 6 elevator. This is also a very bad design because imagine if you are standing here, even the lift is arriving too far. By the time you go there, the lift door already closed. So this is also not practical. 8 elevator in one band, and then the distance is too far. What is the rule of thumb of the distance between here?
I guess not more than 4 meters.
The distance that you can reach lah. So for the lift arrangement, this is the structure type lah. This one is the square type lah. Which one is better?
Depend on application.
Depend on the application. Actually, depend on the application. But for most of the building, we will have a combination of these two. Sometimes we need to move in the back for the ambulance, for the structure to go in. And sometimes when you have the furniture, you are moving your house. And bomba lift usually is this one,
Yes.
long one,
Look like surgery.
Structure lift. Structure lift. What is the advantage of this one or of this one versus this one? Actually, the discharge time for this kind of the structure lift is longer. Because why? You know why? For this kind of lift, you can have bigger door opening. So when the door is bigger, it's actually easier for the people to come in, to come in and go out.
He also allowed double door to open.
Double door. This one also can have a center opening, but quite often we will have side opening. That will be the reason why we need to have side opening. The reason is we can put the counterweight here. And why we need to put the counterweight here? That is also a reason related to traction. Okay, traffic requirement. Traffic requirement, lift traffic analysts could help engineers to determine the right planning for the building, including whether to modernize existing equipment or install new equipment. They can predict how building vertical transportation will perform after upgrade or change. So this one, this is the Albert So lah. I mean the very famous lift engineer from Hong Kong. So he has written fundamental, then you can have a small group exercise. Okay, so what is the meaning of Sang-Wen? This word. This keyword.
Modernize.
Modernize.
Like I think just now you mentioned the conventional elevator got motor room one, the new one without the motor room one. The modernized
That one is a replacement.
Let me try. The modernizations of the old systems probably is the conventional non-VVEF system, then you modernize your VVEF system.
Yes.
The
Yes.
control.
Mainly on the drive side lah. And then some of the modernization is what we change the control system. Last time you still remember they have the 7-segment display. We modernize the control system so that we can have a dramatic display, and some of them even have the LCD display. We have it. And then another thing is last time I also did propose to the client, instead of the fluorescent tube, I think in the last those days the lift they have the fluorescent lamp now. So we upgrade to what LED.
In way forward, I think in near future you have AI control and certain features that like Dr. Lee mentioned, pre-book, pre-record, no need to press, the 4M phone, IoT, booking. Yeah.
Some 15 years ago, my experience with AI lift was at the UITF Shah Alam. Usually in the elevator we have only two choices, right? Up or down. But when I saw the panel at UITF Shah Alam, it was full of digits. So means that you enter your desired floor directly, and then the computer will calculate which lift to assign to you.
Oh, that one is actually quite
15
some time
years
ago.
ago.
Some time ago already.
15 years ago.
After that, I have not seen any type of this kind of lift or control system elsewhere.
Oh, okay.
Straight away, let's say you wanted to go on 10th floor, then press 1, 0, then you just wait, then it will assign which lift to come and pick you up.
Okay. But now also same if let's say you make a landing call, I think with the group control system, they will also have the algorithm to send the nearest floor, the lift from the nearest floor to
That
serve.
is calling what he said right now.
While
While waiting outside without pressing the button, then you won't, like call
While
button,
waiting.
yes, you will able to know, but you don't know the final discharge point. But this case, you will
already
be
knew the destination.
both the
while waiting.
arrival and at the same time discharge two in one.
Yes, while waiting for the lift to come, you already enter which floor, so that a lot of people enter. Then you will know which floor for which lift.
So interesting,
Interesting.
This
Maybe
is
also
free.
probably will predict the number of passenger.
Passenger.
Yes.
Okay, another question. From my working experience, because I was the pre-opening team member for the new hotel, so I visited the control room. The control room, usually we only hire the elevator company technician to service our elevator, the hotel elevator. But there's one time we also conduct the fire drill for the hotel staff. That time I was in another security room, the control room, and then there we got a lot of buttons that there is some machine that we can control the elevator from that security room.
Possible, can?
Yeah, I want to know to what extent the control room, I think the control room elevator control room can manipulate a lot of things, can control the entire elevator. Then the security control room, to what extent they can control the elevator.
Actually, there are 3 levels of the control.
Yeah.
There are 3 levels of the control. Okay, when you go into the lift, the first level of the control is actually you press the button, no?
Yeah.
Lift will move up and down. No?
Mm.
Another control is at the motor room. No?
Yeah.
But security room, I'm not too sure. Usually in the motor room. And then another control is actually at the lift car top.
Yeah.
At the lift car top. When during the maintenance, the technician will go to the top of the lift so they can press the lift up and down. So the lift car top control can override the control at the lift car and also motor room.
Oh.
So let's say I'm a lift engineer, when I go into the lift car top, I can press one switch, that means only the car top control up and down will take place. Why we need to set that kind of the procedure or priority? Actually to ensure the safety of the technician inside the lift shaft.
Yeah.
3 level. The second level will be motor room. Motor room.
That time I have the access, but the motor room I let the elevator technician to service. Then during the fire drill that time, I was in the security room, control room, but I just supervise the whole thing, make sure no other people to manipulate all
fire
the,
drill fire drill operation.
But I know that there is some panel there that can control even the elevator as well.
But usually, okay, I do not know how
yeah.
but what I know is usually the lift control system linked to the security room is actually the signal, no? The lift floor, fire lift, and then also the so-called the call, intercom, intercom to alert the security for the evacuation, in case of what? Man trap,
Yeah.
Okay.
Okay, thank you.
Okay, I also forgotten a lot already lah. So this is the lift fundamental of lift analysis lah. So I think maybe we can have a small discussion, small group discussion. So I think the topic that we can discuss is what why should we study traffic analysis? Maybe we can. Why should we study traffic analysis? This is a group discussion lah.
To minimize waiting time
Huh?
of the passenger.
Okay, actually is to analyze the traffic pattern of the vertical traffic pattern based on the application of high density office, low density office, commercial lot, or maybe hospital. Yeah. So from there, the lift engineer can actually design the grouping of the lift to satisfy 2 criteria. What are the criteria we mentioned just now?
Round trip time and also the 5-minute
Yeah, no? Average waiting time, round trip time, and also 5-minute handling capacity ratio. So how can we reduce the average waiting time?
by having more lift in group.
More lift in group. How can we increase 5-minute handling capacity ratio? Bigger lift, bigger capacity. Okay. Then type of traffic Type of traffic is what? Up peak interflow and down peak. So parameter for the up peak and down peak. So actually I can share This is a very good article in which I spent a lot of time to study also. Okay. Oh, slow okay. So yeah, Hong Kong. So actually, if you are interested in the lift technology, you can always Google elevator work. This is the so-called magazine professional magazine for the lift engineer. For the so this they will give a lot of detail related. So there are some formula, okay, yeah. So vertical of the vertical road, cab or car inside the tall building, the obvious function is to transport the occupant. So this is understood. There are some formula. Now this is the Chartered Institute of Building Services Engineers, CIBSE. They have a lot of information on the lift design. And then this is now okay. There are 7 steps for the design step Collection of the building data and population. That one we can understand from architect. So the selection of the lift traffic analysis method. Usually we will consider morning uppeak Then selection of the design criteria, choose of the the lift configuration. I mean 4 in 1 row and so on. Execution, fine adjustment and documentation. So I think Corny they have the software online to do the simulation. Corny they have.
I feel it's free lah.
Free lah,
I feel it's free, a
free lah.
basic one.
Basic
If
one.
you have limitation to choose a group.
Yeah.
Most of the case will be only resi and the office very commonly. Unlike special, you may have to go and look for the
expertise.
expertise to help to generate the simulation.
So you see okay, uppeak traffic is the most important So in comparison with the uppeak downpeak tends to be shorter So usually we don't take I mean it's lunch mixed peak. Yeah, I think that one is also not our main concern. Parameter involved. So this is the important parameter. So this is the equation Okay. So the number of the passenger in arriving is here. So this is the parameter. This is the factor and then n is number of floor and so on, and then they are also the time. Okay, uppeak, RTT, interval and handling capacity. So the process start when the empty cab arrive. So this is the round trip time
Yeah.
number of floor and then number of the stop. Number of floor, number of stop is actually correlated to number of floor. The more number of floor, the more stop it will be So they are formula. So it is actually the probability So because it is not possible for the lift to make a stop at every floor Okay, so we need to consider time to accelerate, decelerate Okay, so this is where time to accelerate and decelerate is actually closely related to VVVF. Because for the inverter VVVF, actually the acceleration and deceleration could be faster. Because conventional one, like I said, when they have the so-called the star delta, and then it will take time to move. Because the torque is higher. So this is the round trip time. This is the long formula. Okay, so we will need to consider the door opening time, door type, number of the people. Usually we consider 80%. For example, if let's say your lift can accommodate 10 people, usually we consider 8 people enter the lift. You see now. Okay, upgrade. So these are the formula. Elevator kinetics. So these are the kinematic. So the time profile from one floor to second floor. So as you can see, this is the velocity. This is the time. So what is this? Acceleration.
Yeah.
Acceleration. deceleration. So actually, when the number of stop is increasing, actually the lift may not have the chance to reach full speed. So that's why you have a different, sometimes you have a different profile. They may not have a chance to reach the full speed. Okay, so these are the analytical model. Okay, these are the analytical model. Highest reverse fall and expected number of stop, what I mentioned just now. Okay, so these are the formula mathematical model. Okay, so there are also some example, but usually we don't really go into the detailed calculation now. So as I mentioned, they have some software to simulate. You just have to key in the capacity of the lift, number of the floor, then it will compute the number of the probable stop by itself. Okay. Anything?
Previously there's a WhatsApp video lah. Someone took a electronic vehicle or something, electronic bike inside the elevator, and then when the elevator door closed and moving, the electrical bike or something burned, like got fire inside the elevator. Is it the elevator when moving causing some electromagnetic wave and then cause the electronic bike to burn?
No,
Because there's a video circulate in the WhatsApp.
I don't think so.
No, no.
Not
So it is safe to bring in electronic vehicle inside the
If let's say you have the car, if let's say you have the car lift, what we need to consider is the capacity of the tonnage only and the size only. We don't really bother whether it's a.
If you that case now, the car lift is basically all the cars going.
So that video might be some other reason
For sure.
some other reason, not because of the elevator.
I don't think so.
Because there's a video circulate.
Not the elevator causing the fire for that particular.
It's a problem on the
It's by
vehicle.
inside the vehicle itself.
You should
vehicle itself.
you should consider elevator is just a cage.
Because it's not generated any waveform and causing
will not.
No.
In fact, it's sealed. So usually you signal loss, you won't receive. It's just a sharp make of concrete and with the car cage.
I think a few months ago this video circulated in the
Not true,
Not true one, right.
to us.
Thanks for clarification.
No problem.
Very well thought.
So solar Okay, so this is the sifu for the lift analysis. Okay, so now we talk about a more comprehensive topic So this one will really quite heavy one Motorroom, lift shaft, traction, door and safety component. So last time actually I was a chief engineer to design the motorroomless lift for my company Fuji Lift and Escalator. And after that, when the company closed down after acquisition by another company, they set up another company and they purchased the equipment from China lift factory. I was the one who set up the system. Set up the system. Okay. Okay. So this is the design. So this is the design and construction of lift system. So typical lift system. So this is the motor room. This is the lift shaft. So this picture, this diagram is actually from the guidebook, Chartered Institution of the Building Services Engineer. So typical is the lift car, and counterweight attached to the separate ends of groups. The key word is separate end of group. Walk over the traction drive. Wrapping. Coupled to the motor. Another keyword. The shift must be coupled to the motor. Friction between group and groove of the shift will generate traction. So that's this answer to IR Chan question. Why we must use group? Why not chain? Because chain you do not have enough surface which can generate sufficient traction. Okay. Rotation of the shift will move the rope synchronously, the keyword, in such a way that lift will move up and down depending on the rotational direction of motor. Keyword synchronously. If the shift move 1 meter, the rope did not move 1 meter, what will happen? You will have floor error. You will have floor error because the movement of the shift is regulated and monitored by the encoder of the lift attached to the shaft. So they will have the algorithm to calculate the distance. Actually, there is a method to calculate to correlate the rotation to the vertical movement. We call it calibration. So that is how we install the limit switch and also set the so-called door zone. Okay, car is structure made of steel to carry load. Okay, so by law, factory and machinery XA by steel. The law says so. If you say we have a polymer, can we use that to construct a lift car or not? Sorry, because the law say must be steel. Maybe can get the exemption now. Maybe counterweight is to balance the rated load maximum 50% so that power capacity could be reduced significantly. What does it mean? What does it mean? Why we need to have a counterweight? Actually, you can see the counterweight. Okay, for example, the tower crane, there is also counterweight, But why we need to have the counterweight? And you see, the counterweight is to balance the rated load. What does it mean?
You don't need to use the energy to lift
for-
the things because the weight will help to carry the
For
load.
for crane one, let's say for crane, when we move the crane, it will swing. So the counterweight for the thing not swing.
Okay, that is actually one of the reasons.
Uh,
Correlate to the first statement. Separate two ends. So that must be the ending of the loop.
yeah.
So this is the one. Good guess. Another thing is to balance the weight. Let's say for example you want to design the lift for the 1000 kg. Without the counterweight, you have to size the motor to carry 1000 kg. But with counterweight, you can reduce
Yeah.
You reduce the load that you need
Yeah.
to
Reduce the
Yeah.
electricity.
No, the load, mechanical load.
of course indirectly also generate less energy
Less power.
power
Yeah,
to
less
carry.
power.
Okay. So the counterweight have to be balanced the lift car load first, then only plus the rated load. So that's why for the counterweight, we can put the feeler weight. Black color one. Okay. So major safety devices, suspension rope lock, overspeed governor. So overspeed governor actually you cannot see, but in the motorologist you can actually see there is actually the electromechanical part with the shift attached to the lift car with the safety rod. So when this lift car goes down and then over the tripping speed, I think there are two tripping speed. One is mechanical tripping speed and another one is the electrical tripping speed. So the speed governor it will catch, then but the lift still go down, that is actually the safety the shift attached to the safety rod, then it will engage, pull the safety gear, so the whole lift will stop. So this is the overspeed governor. A device to govern speed of the lift by means of locking of flywheel hook on the shift using the centrifugal force principle. Do you know what is centrifugal force principle?
centrifugal.
They are actually a
Racing
roller or ball lah. So by the time it rotate fast enough if the ball will actually
离心力
I mean lift away and then it will causing the tripping it will hook up. Or safety gear, a pair of well shaped jaw will grip the guide rail upon activation of the safety rod link onto the safety group speed governor room lah. So a question when the safety gear engage can it stop the lift immediately or not? Can or not?
It has to.
Cannot.
Cannot. It must be having the sliding speed, sliding distance. Depending on the speed, the higher the speed, the longer the sliding distance. Because if let's say imagine the lift go down in a very high speed suddenly stop the lift stop due to the inertia
G-force.
fracture yes
G-force.
G-force yes so it must have the so-called the sliding speed. So the safety gear that we are using for our lift is actually called non-instantaneous safety gear. But for dumb-waiter and good hoist, yes, we can have an instantaneous safety gear because no people inside and also low speed. So that is the difference. Okay. So landing door lock device, electromechanical lock to prevent unintended opening of landing door. What is the keyword?
Unintended.
Actually, in the past, long time ago, people can actually open the landing door.
Yes.
But now cannot. That's why for the lift door, they have the special triangle key. Last time I have. that kind of key is actually the restricted tools. Only can be given to lift technician. I think Bomba have and security. I think last time we did not give to security.
Under training, then they
only
authorized letter.
authorized letter.
From Bomba,
From
showing that
Bomba.
this group of people have been trained,
Uh,
only allowed the donkey.
donkey. Okay, but now we also have another door lock device, lift car door device. Why last time they only have the landing door lock only because why? Imagine if let's say the lift is here if let's say you open the landing door, what will happen? You fall down. Yeah lah.
So now have to interlock between the car and the landing.
Exactly. Interlock. So a buffer. A buffer. So a buffer actually is the so-called device to reduce the impact of the lift car. Just imagine even though the safety gear also did not work as well, so the lift continuously fall under the gravity, so it will hit the buffer. So there are two types of buffer. One is actually oil buffer, another type is a spring buffer. Spring buffer is designed for the lift with the rated speed, I think maximum 1 meter per second or 60 mpm. After that, we must use oil buffer so to reduce the impact. So that's why for the lift servicing in the lift pit the technician must check the oil. If you have the oil leakage that means when the lift go down and when it hit the buffer if let's say the buffer did not compress then you have a big shit then you are in big shit.
Spring type no need to check.
Spring type of course but spring type only can be used for the low speed. Low speed means what? Low fall, low travel. Low travel. Okay. So far okay So this is a lift car. So this is the counterweight, suspension rope, overspeed governor, safety gear, car buffer, counterweight buffer. Why we need to have the buffer for counterweight also? Why? If you don't carry people, why you need to have the buffer also? Why? Stupid, huh? You not carry people, why we want to put the buffer there? Any reason or not?
In case maintenance, during maintenance, they need to adjust something or
In the event, now just now we mentioned, we have the counterweight balance 50%. What will happen is the lift car lifted load is less than 50%. How? When the shift give way or what, counterweight will be heavy,
yeah, heavier.
more heavier, so it will go down. So we must stop the counterweight, otherwise the lift car will overshoot and then hit the wall of the motorroom. So that is that, and then that is a method to calculate the overhead. No? The calculation of the overhead is depending on the maximum travel in the event the counterweight hit the buffer, so that to ensure that the kinetic energy of the lift car going upward can only travel to certain level. We still have some space before it hit the motorroom wall slab. So that is the reason now. Yeah, this is true one, this is engineering one, correct one. So okay, design and construction of lift system. Controller is the heart of the lift system. It comprises main control unit, we call MCU, inverter, transformer, switch mode power supply, and wiring connected to traveling cable. Okay. So here, what is the keyword?
Safety gear.
So the keyword is actually traveling cable. Traveling cable. Because the lift car is going up and down. How the electrical signal been sent to the lift car? By traveling cable.
So same as the same cable as using the CCTV inside
Yes,
the
yes. There are coaxial cable inside the traveling cable. Okay.
Yeah, right.
You are right.
The CCTV inside the elevator.
Yes.
Got now also got another type is wireless.
Wi-Fi.
Commonly using cable
Okay.
in the
using
traveling,
Wi-Fi.
Okay.
traveling cables.
Car guide rail is a pair of the T-shaped steel used guide movement of the lift car and counterweight, and also allow gripping of the safety gear. Actually, in the past, there are two types of guide rail. No? One is a solid guide rail, another one is a hollow guide rail. In the past, they allowed to use a hollow guide rail for counterweight, but I think now they no longer allow because of the rusty. Last time I think we have the guide rail hollow one. Traveling cable is used to transmit electrical signal between car door junction box and the controller, and also supply power to car door operator, because your if car door there is a motor which drive the door to open and then car door cam will engage with the landing door hook to synchronize opening of the landing door. We call it door zone. I think there is a car cam. When it reach the so-called the door zone, it will engage with the landing door lock. But once a motor drive, it will pull the so-called the landing door together. Okay, then we have another thing so-called apron. Now this is apron. Why we need to have apron? Underneath the lift car, there is a steel sheet. Apron. Why we need to have apron?
When you level, it allow certain level.
The height of the apron, I think, is 950 mm. So in the event the lift car stop here, our door opening height usually is how many? 2 meter or 2.1 meter, correct or not? If the lift is stopped somewhere, without apron, there is a chance people will fall down. So we need to have the apron to block, to eliminate the lift.
Just now mentioned the interlocking is only allowed to open on certain height, only a level. If really properly too much unlevel, you can't.
You can't open because there is no engagement between the car door cam and the landing door lock.
That's what they explained here.
And then the door zone is 200 meter up and 200 meter down because that is the length of the car door cam. Okay. Then governor tension shift. This one also very important. This is must check one to know because this is a speed governor rope. So when there is the rope, we need to maintain the tension so that the rope tension is remain. So when the upper shift lock or stop, the shift the rope can stop accordingly with owing to the tension. If this one tension is not properly controlled, that means when this shift stop, the rope may still running. Okay. So landing push button human machine. This one is normal one. This is what we call for us to push. Then landing indicator. Landing indicator is here stop. But I think nowadays they seldom put in the indicator at the top anymore. They usually put in the door matrix or LCD at the button already. Because you know why? You need to have another hole. So nowadays they no longer using this. So another thing is the limit switches. Limit switches is actually a very important devices to stop the lift before it reach the car top and also reach the overhead and also the pit. Although we have the safety gear, we have the so-called whatever protective device. The limit switches is actually to cut off the electric power. Limit switch. Actually, for most of the lift, for low speed, we have the 2 limit switches. So the first limit switch is actually to trigger the slow speed. Then after that, just I think some particular distance above the buffer, there is a final limit to ensure that the electrical power supply is cut off. Okay, so this is the lift layout plan. So this is what we usually have. I think this is the motorroom. Motorroom. So this is the arrangement of the motorroom. Then this is the typical hoistway plan. So this is the run by. Run by is a distance between counterweight and the buffer when the lift car at the highest floor. So this is the hoistway. So lift car size and so on. So to ensure that sufficient clearance are available, a person working at the car top or pit will survive in the event of lift overrun due to severe malfunction. So we need to have a sufficient clearance. So what is this? Ladder. So nowadays the ladder is usually at where? At the side, at the side. Usually.
Yes, I think. Usually cat ladder is also not this kind. You have to have some safety what call real
Enclosure. This is what? Car top safety wheel. So to prevent people from falling down. Why it needs to be in yellow color? Maybe you can give a guess.
Visible. Yellow color, even in dim light or not, they still visible.
Exactly. Because
you can see in the dark also can see.
You can see. But actually under EN81, it is actually mandatory to have the lift sublighting. But I think in Malaysia not really.
All car above the car got separate and they need to service, they need to on it.
Car lift.
Now car also have extra battery and something to operate.
Okay.
During the emergency, they got e-box.
So the minimum clearance and the lift pit measure from the bottom cross section. This is the bottom the lowest part of the lift to the peak floor must be 610.
Just for information right now, even for the lipid access, you have to be now new rules people for escape. I think some people are struggling how to the people servicing it have alternative way to exit.
Yeah,
But
that's it,
lipid, there's is something on discussion.
yeah, something in discussion. No?
In discussion, sorry.
Okay, so this is a river. Another thing is there shall be a clearance of at least 610 mm between the highest point of the traction machine and the motor room. Usually we will have the hoisting hook or the hook, the beam or the hoisting hook. This why we need to have the clearance of the 610 mm so that we can put the chain hoist or chain block
Yeah.
to
Yeah.
chain block or in case of major repair. So far okay, clear.
Yeah.
Okay, so we recap. Okay, so we have talked about lift lift car. Traffic and traffic. We talk about average waiting time. We talk about round trip time. Then we talk about the construction. We talk about motorhome. We talk about lift car. We talk about guide rail. We talk about safety gear, overspeed governor, and so on. And then we have also talked about the requirement of the clearance to safeguard the people, and then maybe we can have a small discussion on possible arrangement of the lift and counterweight inside the lift car. So just now we have mentioned for the long lift, actually we can put the counterweight at the side. We can put the counterweight at the side. Why? Because that is the distance between the so-called the counter, the so-called the center of the car, where the rope ends between the car and the counterweight. It cannot be too far. No? It cannot be too far.
Since the motor also is sometimes it's not the direction is can be slanted way. It's not necessarily horizontal or vertical. It can be slanting, mounting it. So some of these designs.
Yes, can be. And then when we have the bracket, the counterweight, we call it side drop. No? When the counterweight is actually at the side of the car, we will have a share bracket. No? That means because that means in order to hold the guide rail, we need to have bracket. So now when we have a so-called back counterweight, we have a car bracket and counterweight bracket. But if we have a side drop, actually the bracket of one side of the lift car can be shared with counterweight. I think you've seen that before. I think you've seen that.
So it's a side drop better than the conventional.
Not necessarily. If let's say you have square type of lift car, usually we don't use side drop.
Only rectangular set.
The stretcher type. Okay, so we have recap. Okay, so now you want to continue? Continue now.
Okay.
Continue. Okay, continue.
Continue.
Okay. So now we talk about the traction machine and the looping system. So the size of the traction machine starts with the simple equation: power equal to force times speed. For the lift, we consider 10% load margin. Load margin. Let's say for example, 1,000 kg, we actually will allow some more. We will allow some more. And then this is the formula. Okay, balancing factor. Balancing factor means the counterweight factor. This is the A and G is the gravity, V speed, then efficiency coefficient. So this efficiency is dependent on what kind of the machine you are using. So therefore, power in the lift is P. So this is the formula. Okay, and then for example, load 1,000 kg, speed 1 meter per second, balancing factor of 45%. That means counterweight will take up will balance 45% of the load. Efficiency 0.9. I think that one is a very high efficient machine. So the required minimum power is 7.08 kV. Okay, if let's say some of the motor they in the past when we use the worm gear motor 7.08 kV we have to use 7.5 kilowatt motor machine. This is how we size the motor Okay, when we size the motor 7.5 kilowatt can we size the inverter size also 7.5 kilowatt?
Usually bigger.
Will be one size bigger due to the marginal condition. Good experience. Okay. Take note this equation is for all roofing configuration Why If let's say you have 2-to-1 roofing your load will be divided by 2, but your speed will be times 2. So actually it cancel each other Worm gear machine, gearless machine for installation on the beam. So these are the footing. Gearless machine with metal belt 3 belt. Gearless machine for installation on guidance. This one is the intellectual property of Kony. This one actually save a lot of space. Traction machine installation. So now we see. So this is the machine backplate. This is the I-beam which will take the load of the machine plus the lift car and the counterweight. So this is the deflector sheath. So why we need to have a deflector sheath? What is the reason why we need to have a deflector sheath? Deflect.
Adjust the tension.
Because the diameter of
Size.
the sheath is fixed one for 560 mm or 480 mm, but your distance between the car guide and counterweight guide could be bigger. So you need to have deflector sheath. Okay. So this is the machine backplane. So why we want to control the distance between this sheath this end to this end because the longer the distance the higher the machine backplane. Because you know why? You need to guarantee sufficient wrapping angle between the roof and sheath.
Yes. Okay, touching. Yes.
Still.
Good.
对吗？是吧？对。So that's why for the long lift long spectral lift we put the counterweight at the side. And then some of the design we orientate the machine in the slanted angle also to sometimes minimize
That's why slanting,
So this is for the worm gear. This is the drive motor. So this is the drive shift. Brake drum. This is the gearless. So this one is the double rack shift. What is the meaning of the double rack? That means for the high speed lift, because for this one even though the lift let's say during the emergency and the safety gear already engaged if let's say the speed is too high and due to the ignition the roof will still move. So for the very high speed lift we have the double rack. So means the roof will do one round and then second round only it go to the lift car and counterweight. So it prevents the loop slippage during the safety gear operation. 一架掉佢未走，就是講伊 lift 停伊冧伊 loop 袂使對了走，佢袂使走嚟掉。So that is the reason why they have the double wrap design. Very high speed lift only we have this Okay, roofing ratio. Roofing ratio is the ratio of the roof speed, car speed. For 1-to-1 roofing, roof speed is the same as the car speed. For 2-to-1 roofing, roof speed is the twice of the car speed. For the roofing factor ratio more than 1, suspension shift are provided. You see? That's why for some of the lift we see the shift on the car top. Oh, so this is what we see. So with this roofing system, load on the lift is reduced to 1.2 or 1.4. Hence the diameter and number of roof can be reduced. So, but let's say for example the machine for 1000 kg 2 meter per scan, it can be used for 2000 kg, but the speed reduced by half. With the 4:1 roofing, the load can actually be going up to 4 tons, but the speed reduced to 0.5. So that is how the lift engineer play around with this roofing factor. Can see a lot. Okay, 1:1. This one the double rack. This one is a drum. So this one, I think this one is usually for the hoist. That means there is a drum. The coney drum. It actually retrieve and then release. So these are the roofing factor. This is the car bottom lift. So this is actually, but some of them are not common one. So, but usually the common one is actually 2:1. Actually, our motorhomes is also 2:1 because they have the car bottom shift. So how you define? So this one is what? This one is what is the roofing factor? 1, 2, 3, 4, 5, 6. 3:1 single rack, half rack. That means at any point of time you can see 3 roofs. So this one is 2:1. At any point of time you have 2 roofs. You have 1 shift. So this is how we assess. So 2:1 configuration. That's what I mentioned just now. How I explained. Because when you have a 2:1 roofing, the travel of the speed of the roof and the speed of the lift car is actually different by half. Yeah, continue. 4:1 roofing even higher. Tapi ia lam si kaya sipai here. Okay, roofing configuration.
Thank you, doctor.
You
Thank you. Stay safe.
stay safe. Okay. So we talked about roofing factor So can we have a car and cannot pay Okay. And counterweight with a different roofing factor. So for example, we want to have the car 2:1 roofing but counterweight 1:1 roofing. Possible or not? Just like I mentioned for 2:1 roofing, car must have 1 pulley counterweight must have 1 pulley But can we do that or not? Lift car 2:1 roofing, counterweight 1:1 roofing, can or not? Possible or not? People ask me before. They say, hey, why you want to put waste another ship? You're stupid or what? Why you can or not? Technically can or not?
I think can.
Never mind. We go through together. The answer is no. Because the lift will travel at the half of the counterweight speed. Therefore, before it reaches the counterweight will either shoot up or shoot down.
So quiet.
Double already.
Maybe very slow speed, then possible.
Pardon?
Very slow speed.
Also not possible because it related to the travel the distance
So the ratio is always fixed.
No, listen.
So, people ask me this before, but I told them cannot Okay, these are criteria. So maybe we take a short break Maybe we take a short break.
想乜嘢啊？講乜？
Counterweight is 50%